Well, hello and welcome to the second chapter of Anatomy and Physiology. What we're going to be looking at today is basic chemistry. In other words, we're going to start off with just looking at chemistry, but then we're going to eventually get to how this actually affects the human body, which is now known as biochemistry. First thing we want to wrestle with is matter and energy. And the real question is, what is matter? Well, matter is anything that takes up space and has mass. Anything that takes up space and has mass. In other words, matter is the stuff that makes up the universe. All things that we can physically see, physically touch, and feel is made up of matter. Even wind has matter within it, and that's why it has effects on other things. Now, matter exists in 4 states, 3 of which are more common on Earth than the 4th. But the primary 3 ones that take place here are right here when we're dealing with solids, liquids, and gases. All bits and pieces of matter can be found in one of these 3 forms on planet Earth. A solid is when something has reached a point where it becomes tightly packed together, where the atoms do vibrate, they do move, but they move at such a small amount, but at very, very high frequencies, but they're tightly packed together, and that means that they're solid. In other words, they're in a frozen state. Whereas we think of frozen as in when water freezes, but all things have the capacity to freeze. All physical things have the capacity to freeze, but just many objects that we see, actually their freezing point is a very, very high temperature. It's not room temperature. It's actually higher than room temperature. And if they get hot enough, though, they then will turn into a liquid. Water actually has a very low temperature melting point. And something goes from a solid to a liquid, it's said to be melting, and it's reached its melting point. Liquids are very, very common, are very important. Water being the primary liquid that we deal with almost all the time when we call it a liquid, because at room temperature it's at liquid form. Can water become solid? Yes, that's what ice is. Can it become a gas? Absolutely. That's what we call water vapor. Or steam. When liquids get heated up enough, they become gaseous. That means they turn into a gaseous form. Liquid is not nearly as tightly packed together as solids, and that makes them capable of rolling over the top of each other, giving them that fluid-like texture. Whereas when they become a gas, these guys are becoming superheated. These guys are becoming highly energetic, and they're bouncing away from each other in all different directions. That's why gas is said to have no definite shape or no definite volume, whereas liquids are said to have a specific volume, but they don't really have any specific shape. Whereas a solid is said to have both a definite shape and a definite volume. It's not going to change shape just because we move it from one container to another. Whereas a liquid, if you take water and you pour it out of a bucket into a glass, it's going to not keep the shape of the bucket, it's going to change to the shape of the glass. You pour from the glass onto the table, it's going to spread out and try and fill up every bit of that room that you just spilt the water in. Why? Because it doesn't have a definite shape. It's willing to match any shape of its environment that it's in. That's one of the qualifications for a liquid. Gas will literally fill up any empty space that it's in. The room you're sitting in right now is filled with gas that is filling up every single empty space that you think you have. Technically, we don't actually have empty space on planet Earth, because the actual definition of space is the absence of matter, which is literally what you have in the vacuum of outer space when you get outside of our atmosphere. Now, the 4th state of matter is known as plasma. And the reason it's not as common here is because very few things get hot enough to reach plasma form. We have one form of plasma naturally forming on planet Earth outside of a laboratory, which is when we have lightning, and that is in a plasma form. But plasma is the most abundant state of matter in probably our galaxy, I know in our solar system, but possibly even in our galaxy, even in our universe. Why? Well, because our sun is all plasma. And our sun makes up 98% of all matter found inside of our solar system. Okay? Now, with that being said, let's move on. Like I said, matter is anything that occupies space and has mass. Mass also being known as weight. Now, energy is the ability to do work, chemical, electrical, mechanical, or radiant. Now, energy in itself cannot be felt, can't be touched, necessarily can't be seen as a physical entity. However, energy has effects on matter, and that's how we measure it, what it does to matter. Now, we do know that energy has the ability to go through what we call conversions. Now, I want you to know these two laws. These are called the laws of thermodynamics. Thermo meaning heat, dynamics meaning movement. The two primary laws of thermodynamics, and these are also carry over to the laws of conservation of matter and basically a lot of other physics laws. But these are the primary laws that we need to understand for a lot of things that we're going to discuss later on. The first law is this: energy is neither created nor destroyed. That means energy is only transferred. It's only going to be converted from one form to another. It cannot be created. As a matter of fact, I had a chemistry professor who gave me a bad grade on one particular problem because I stated within my problem that I had created something in the lab. And she marked down, she said, "You can't create anything. You can convert things, but you cannot create anything because you are not God." So I learned my lesson on that one. But we can convert energy from one form to another. We see this happening all the time, specifically even in our own bodies, where in our bodies we will often see this conversion of energy throughout all living things. First of all, we get radiant energy that comes from the sun into our atmosphere, and then it's collected by plants through the process of photosynthesis, where they take a combination of hydrogen and carbon dioxide, or water, hydrogen, H2O, water, and carbon dioxide, and that light energy that they're receiving from the sun triggers a chemical reaction. So here we have a conversion from radiant energy to chemical energy. That chemical reaction then causes a formula or a substance known as a molecule known as glucose. That's C, carbon 6, hydrogen 12, oxygen 6, and O2, pure oxygen. When this happens, the plant will release the oxygen and it'll take the glucose and it will break it down through another process called cellular respiration. This glucose is then in turn going to be turned into a high energy molecule that all living things use, known as ATP, adenosine triphosphate. Alright, now ATP is used in cellular respiration. That ATP is then converted into electrical energy inside of our bodies or inside of plants to send neuro impulses or nerve impulses kinetically through the body to perform all kinds of different functions that the body is going to perform. This is a perfect example of how we see a conversion of energy. But it's also important to know that the second law of thermodynamics. The second law of thermodynamics states this, that all things are moving to a steady state of entropy. Now, what is entropy? Well, basically, entropy is basically an idea that is saying all things are going from high organization to gradually chaotic type of organization, or less and less organized situations. Our universe is expanding, and the idea is that one day it was going to expand so far that it just completely rips apart and separates from itself. Our bodies, as soon as we're born, begin to go through various forms of decay and breakdown. Our bodies begin to age right after birth. Yes, we will live for a while and we'll see young, we'll get stronger for a while, but then we hit that top of the hill and then we start to decrease in organization in our body, and our cells begin to be less functional, and they start to have problems, and they produce crazy cells that don't work properly, and that's what we call a tumor, and then or cancer, and our bodies begin to break down. So we already see the second law of thermodynamics in work in ourselves, in our own bodies. That is energy.